Hello, dear students. Welcome to this lecture, Introduction to Econometrics. My name is Dr. Ensa. The first topic which I am going to discuss today is nature and scope of econometrics. The various learning objectives of this session are to understand the meaning of econometrics, to know the utility of econometrics discipline, to learn the methodology of econometric inquiry, to learn the various types of data which we encounter in econometrics analysis, and finally, to know the role of computers in econometric analysis. So, let us first discuss the meaning and nature of econometric analysis. Econometrics is relatively an advanced branch of economics, which has grown as a separate discipline enormously in recent times. It mainly deals with measurement, modeling, and empirical verifications in economics. Econometrics heavily borrows its tools and techniques from mathematics and inferential statistics. Therefore, it can be aptly said that it is a combination of economic theory, mathematics, and inferential statistics. The meaning and the scope of econometrics will become evident if we look at the quotation from the opening editorial of Econometrica written by Ragnar Frisch in 1933. But there are several aspects of the quantitative approach to economics, and no single one of these aspects taken by itself should be confounded with econometrics. Thus, econometrics is by no means the same as economic statistics, nor is it identical with what we call general economic theory, although a considerable portion of this theory has a definite quantitative character. Nor should econometrics be taken as synonymous with the application of mathematics to economics. Experience has shown that each of these three viewpoints, that of statistics, economic theory, and mathematics, is a necessary but not by itself sufficient condition for a real understanding of the quantitative relation in modern economic life. It is the unification of all three that is powerful. So, from this definition, you can easily make out that econometrics is a combination of economic theory, mathematics, and inferential statistics. So, as I told you that one can infer from the above statement that econometrics makes use of economic theory, mathematics, and statistics, but it is an independent branch of economics. Therefore, it must be read as a separate discipline. This becomes clear if we look at the subject matter of other related disciplines: economic theory, mathematical economics, economic statistics. So let us look at these discipline, and we will come to know the utility of econometric discipline. Economic theory. The economic theories basically make postulates that are mostly qualitative in nature. For example, the famous law of demand by Alfred Marshall says that when there is a decline in the price of commodity, it is expected to increase the quantity demanded of that commodity, other things being equal or ceteris paribus. However, the law itself does not provide any numerical estimate of the relationship between the price and the quantity demanded. In other words, it does not tell you by how much the quantity demanded will change due to a sudden change in the price of the commodity. Here comes the job of an econometrician. It is the econometrician who provides such numerical estimates useful for decision making and policy formulation. Coming to mathematical economics, the main job of mathematical economics is to express the economic theory in mathematical form. or in mathematical equation, you can say. For example, expressing demand for cars in linear or non-linear equations. Okay. It does not deal with measurement or empirical verification of the economic theories. So we must keep this in mind that mathematical economics particularly, okay, uh, does not, okay, deal with empirical verification or some hypothesis or testing kind of thing. Okay, it's simply what uh, it does, that it expresses economic theory in mathematical form. An econometrician, however, makes use of the mathematical equations and put these equations in such a form that can further help in empirical testing and verification. Coming to another related branch of econometrics, that is called economic statistics. So economic statistics deals with the collection, processing, and presentation of economic data in the form of charts and tables. The data collected on economic variables such as GNP, money supply, production, investment, inflation by economic statisticians constitute the raw data for further economic work. For example, data collectors involved in collecting information from respondents during some survey. However, an economic statistician does not go any further to verify or test economic theories. It is left to econometricians to verify economic postulates. Now coming to definitions of econometrics. So though it is difficult to define any discipline, and econometrics is not an exception, we will look at various definitions given by econometricians to arrive at the correct meaning of econometrics. No doubt this figure tells you that econometrics is an uh, amalgamation of three branches: economics, statistics, and mathematics. Okay, this we discussed earlier also. Now let us look at some definition. Econometrics is a name for a field of science in which mathematical economic and mathematical statistical research are applied in combination. Econometrics, therefore, forms a borderland between two branches of science. So, this definition was provided by Timbergen. Marshak says that econometrics is the application of mathematics and statistics to economics. Econometrics is concerned with the measurement of economic relation. This measurement requires certain statistical methods, and before one proceeds to measurement, one has to formulate economic relations mathematically. Yes, Goldberger says that econometrics may be defined as a social science in which the tools of the economic theory, mathematical, and statistical inference are applied to the analysis of economic phenomena. Some other definition of economics are given here. Econometrics may be defined as the quantitative analysis of actual economic phenomena based on the concurrent development of theory and observation related by appropriate methods of inference. This definition was provided by Samuelson, Koopmans, and Richard Stone. Henry Thiel defined it as econometrics is concerned with empirical determination of economic laws. So it's a very short definition of econometrics, but no doubt it highlights one of the important aspects of econometric analysis. The method of econometric research aims essentially at a conjunction of economic theory and actual measurements, using the theory and techniques of statistical inference as a bridge pair. So this definition was provided by Havelmo. Spanos says that econometrics is concerned with the systematic study of economic phenomena using observed data. Okay, so we looked at various definition. Let us look at some other definition given by Tinter. Econometrics, the result of a certain outlook on the economics, consists of the application of mathematical statistics to economic data to lead empirical support to the models constructed by mathematical economics and to obtain numerical results. The art of the econometrician consists in finding the state of assumptions that are both sufficiently specific and sufficiently realistic to allow him to take the best possible advantage of the data available to him. So, from the above definition provided by different economists and econometricians, it is clear that three things are core to the study of econometrics, that is economic theory, mathematical models, and inferential statistics. Now, coming to types of econometrics. Econometrics is broadly divided into two groups, theoretical econometrics and applied econometrics. Theoretical econometrics is concerned with the development of appropriate methods for measuring economic relations specified by econometric models. Theoretical econometrics leans heavily on mathematical statistics, for example, least square method, maximum likelihood method for estimation of parameters. Applied econometrics uh, deals with its application in various branches of economics. In applied econometrics, we use the tools of theoretical econometrics to study some particular field of economics and business, like the production function, investment function, demand and supply functions, portfolio theory, etc. There are other branches also. For example, its application in energy economics, health economics, international finance, etc. Okay. Now coming to methodology of econometrics. It's an important question how to carry out an econometric investigation. The process of conducting an econometric analysis may be varied in its approach. However, the traditional approach to econometric inquiry is as follows. So the step one is a statement of theory or hypothesis. Second step is a specification of theory in mathematical form. Next, a specification of the econometric model. Next, obtaining data. Then, estimation of the parameters of the econometric model. Then, hypothesis testing. And next, we have to use the model, estimated model for forecasting or prediction. And finally, using the model for policy purpose. So we will explain the methodology of econometrics using the famous Keynesian consumption function. Okay. So let us look at this methodology of econometrics. So the first step is a statement of the theory or hypothesis. J.M. Keynes stated, the fundamental psychological law is that man and woman are disposed, as a rule and on average, to increase their consumption as their income increases, but not as much as the increase in their income. In simple words, Keynes advocated that when income increases, consumption also increases. Either there is positive relationship between income and consumption. Secondly, the increase in consumption is generally less than increase in income. Either change in consumption is less than change in income. So the first step is the statement of the hypothesis. Okay. So here we have stated the fundamental psychological law of consumption given by J.M. Keynes. Now the second step is a specification of the theory in mathematical form. So the next step in econometric inquiry is the specification of the above Keynesian consumption function in mathematical form. Assuming a linear relations represented by a straight line between consumption and income, the following mathematical model is specified. So you can see here, okay, consumption is a function of income, and in terms of equation, I have specified a linear equation for this particular problem, where C is consumption, X is income, and alpha and beta are parameters of the model. The above equation 1 states that consumption is a linear function of income, meaning they are linearly related with each other. Step 3 is a specification of the econometric model. The above mathematical model in equation 1.1 also says that consumption can be explained in terms of uh, income and income only. The meaning of this is that 100% variation in consumption are explained by the income variable only, which is not correct. We know that there are other factors also, like wealth, habit formation, and taste and preferences that may affect consumption. The purely mathematical model is of limited use as they study an exact or deterministic relationship between any two variables, which is not the uh, case in economic analysis. The relationship between economic variables are generally inexact, and to incorporate randomness in economic relationship, an error term or random disturbance term, okay, it is also called a stochastic random error term, is added to the mathematical model. So after including random error term, the econometric model is given as follows. Okay, so now you can see this equation given in 1.2 is an example of econometric. So we have transformed mathematical model to econometric model. Now, where in this equation, C is consumption, X is income, U is a random disturbance time, and alpha and beta are the parameters of the model. The random disturbance term represents other non-quantifiable or unknown factors that affect consumption. It also represents error on account of measurements that may have entered the data. The consumption function in equation 1.2, okay, which states that consumption function depends on the level of income. In the above consumption function, the coefficient beta is the marginal propensity to consume. And as per theory, it must be positive with a value less than unity. So it must lies between 0 and 1. Okay. The constant or intercept alpha of the function is expected to be positive because even if income is 0, some consumption will be there for survival. So this survival may happen by spending past savings or borrowings or finding other means for meeting expenses. Now, the fourth step is to get data on the relevant variables. So to estimate the econometric model stated above in equation 1.2, that is to obtain the numerical values of alpha and beta, we need data on consumption and income variables. For example, the following table shows average annual household consumption and average annual household income across various cities in India, published in Business Today, dated September 7, 2008. So this data is relatively okay, older one, but uh, this data uh, will help us to estimate the relationship between consumption and income across the various cities of India. Now you can see here, this is the data we have. Okay, this is cross-sectional data, no doubt. Okay, so we have average household consumption in rupees lakh and average uh, income in various cities of India. Okay, in 2008. So now the next step is the estimation of the model. To, as I said that the next step is to estimate the parameters alpha and beta, which determines the relationship in the model. In this stage, we try to find the numerical estimates of alpha and beta. This is done by a statistical technique called regression analysis. So let's say the estimated alpha values of alpha and beta are 0.86 and 0.26 respectively obtained by regression method. Thus, the estimated model is, let's say, this one. Now, the meaning of intercept value of 0.86 is that when income is 0, on an average, consumption will be 0.86 lakh, okay, or 86,000 in India, okay. The meaning of beta coefficient is that when income increases by 1 lakh, on an average, consumption will increase by 0.26 lakh, either 26,000. Fine. So this is how you can interpret the estimated model, and these estimates were obtained from using this data set. Estimation of procedure or estimation process we will uh, look later on. Fine. Now coming step 6 is hypothesis testing. Now we go back to economic theory of consumption function postulated by Jenkins. This theory predicts that income can explain consumption. Does the econometric model support this hypothesis? Hypothesis testing is sometimes called confirmatory data analysis. One use of hypothesis testing is to decide whether experimental or observational results contain enough information to establish some theory. If the theory is found to be correct, then we have a positive result. If the hypothesis testing is positive, the model can be used for prediction purpose. Hypothesis is just an assumption regarding the population parameter. Let's assume that there is no relationship at all between consumption and income. So in this case, beta will become 0. If we can reject the hypothesis of no relation between consumption and income, then it is established that these two variables are related. In technical sense, this is called statistical inference. Now coming to seventh step, forecasting or prediction. If the hypothesis is positive, either the theory is found to be correct, then we can forecast the consumption for a given level of income. For example, how much would someone consume for a given level of income of rupees 3.5 lakhs? The estimated econometric model will give answer to this question. Okay, so you plug this particular figure in that particular equation and you can get the result. The aim of the econometric investigation is to find good numerical estimates of the coefficients of economic relationship and to use them for prediction and forecasting. Now, finally, using model for policy purpose. If the theory seems to be correct and the econometric model was not refuted on the basis of hypothesis testing, we can go on to use the theory for policy recommendation. One of the uses of the estimated consumption function for policy purpose may be deciding consumption level in the economy by the finance minister. Let's say, to contain inflation, the finance minister fixes a consumption level of rupees 3 lakh in the economy. To have a consumption level of rupees 3 lakh, given the estimated model, what would be the level of income in the economy? Using the above estimated model, income of rupees 8.23 lakh ensure a consumption of rupees 3 lakhs in the economy. Okay. Now, we have discussed an important aspect of econometric analysis, that is the methodology of econometrics. So I have discussed all all steps involved in methodology of econometrics analysis. Now coming to types of data we encounter in econometric analysis. As a researcher in economics area, you will encounter 3 types of data basically, and this knowledge of types of data will help you to analyze or research well. So there are basically three types of data we encounter in econometric analysis: cross-sectional data, time series data, and accordingly we have uh, cross-sectional regression analysis, time series econometric, panel data econometrics analysis. Each type of econometric analysis has its own problems and issues and must be taken care while doing analysis. Let us have a look at various types of data. So cross-sectional data. Cross-sectional data refers to parallel data on many units, such as individual, firms, countries, etc., at the same point of time. The following are examples of cross-sectional data. Profits of 50 US firms in 2021-22. Per capita income of 100 nations in 2022. Heights and weights of 500 people in Delhi in 2022. Income, education, and experience of 2,500 workers in Melbourne into, 2022. And now you can see here, I'm having one example of, cross-sectional data. So there are 10 countries I have taken. So these are the cross-sectional units. This is GDP per capita and population of these countries in 2022. Okay, so one can also estimate the relationship between GDP per capita and population. So for that kind of analysis, you can use a cross-sectional data. So this is one example of cross-sectional data. Now coming to time series data, or a time series data is a sequence of observations ordered in time. For example, data on real GDP, money supply, inflation, etc., are collected at specific points in time, say yearly. These data are ordered by time and are called time series. The observations made on GDP or money supply at time t and t plus 1 are separated by some unit of time, such as days, weeks, months, or years. The following are some examples of time series data. UK annual GDP at current price from 1950-51 to 2017-18. Profits of Microsoft company over 20 years. Daily closing price of Nasdaq over 5 years. Okay. So one example I am having of time series data here. US GDP per capita. Okay. I am having data in descending order from 2009 to 2021. So you can see the per capita income of US in 2021 was $69,288. Okay. And this per capita income in 2010 was 48,651. Okay. So in 10 years, I think there is substantial increase in GDP per capita in US. This is an example of, time series data. Now coming to panel data. Panel data contains features of both time series as well as cross-sectional data. In panel data analysis, the same cross-section unit is surveyed over time. The following are examples of panel data. Growth rate of, let's say, M3, broad money of 20 countries from 2000 to 2017. Profits of 100 firms over 10 years. Here I am having one example of, panel data. You can see here that there are three countries: Canada, Australia, and India. And GDP per capita, okay, for 4 years, okay, and per capita consumption. Likewise, we have another, okay, country, data on another country, Australia, from 2017 to 2020, and we have GDP per capita, okay, time, okay, time series for 4 years, you can say. Likewise, we have, okay, 4 years uh, data on India. So this type of data is called, panel data. Panel data is basically helps to, combine both, uh, you know, aspects, cross-sectional as well as time series dimension. Now, finally, coming to the role of software in econometric analysis. Like any other field today, the role of computer in econometric estimation cannot be undermined. The computer facilitates econometric estimation in a large way. Regression analysis, which is the main technique in econometric analysis, is unthinkable today without computer and some access to statistical software. There are many statistical software available for, estimation purpose. For example, SPSS, SAS, Minitab, eViews, RADS, SASM, Stata, etc. are few famous statistical software available in the market. I think particularly SPSS, eViews is very popular for economic analysis, particularly for time series analysis. Stata is also very popular nowadays. Okay, uh, there are also some, software, for example, doing uh, statistical analysis in R or in Python. Okay, these are no doubt programming based software. Regression analysis is also facilitated to some extent by MS Excel. In MS Excel, you can estimate, regression analysis up to 16 independent variables. If you have more than 16 independent variables, then Excel cannot be used for regression analysis. So thank you. I hope this particular lecture uh, has introduced you people to econometrics discipline. Thank you. Thank you very much.